We're in section 5.5, guided practice for L'Hopital's rule. Let's do those last three problems. These are a little tougher, maybe just a little longer, I don't know. But we have the limit as x approaches 0, x squared sine of x, all over sine of x minus x. So we definitely have a 0 over 0 in this case because sine of 0 is 0. But then we use L'Hopital's rule, and so we're going to get the limit as x approaches 0. Now we do need to use the product rule here, right? So take the derivative of the x squared, leave sine x alone, leave x squared alone, take the derivative of sine of x, and divide all of that by, I guess we take the derivative of sine, which is cosine, and x, which is 1. Now at this point, if we plugged in 0, we're getting 0 on the top, but we're also getting 0 on the bottom, right? Because cosine of 0 is 1. So we can use L'Hopital's rule again. And we have another product rule, but let's see what we get. Limit as x approaches 0 is going to be 2 sine of x plus 2x cosine of x plus, let's see, this is going to be 2x cosine of x plus, or I guess I should say, minus x squared sine of x. And all of that is over negative sine of x. Whew. Goodness gracious. Well, let's see what this winds up being. Tell us this gives us something. We have 0 for the first term, 0 for the second term, 0 for the third term. Oh my goodness gracious. Oh my gosh. This is becoming a little much, right? We still, after all of that, get 0 over 0. So let's use L'Hopital's rule one more time. Hopefully we'll get something that we can work with here. One thing to note is that this right here, maybe just make things a little bit easier. This right here is just 4x cosine of x. Right? So anyway, when we do this again, take the derivative, we get 2 cosine of x. And then this is going to be a product rule. The 4x cosine of x is going to be 4 cosine of x. I guess I should say minus 4x sine of x. And then we have a minus 2x sine of x minus x squared cosine of x. All over negative cosine of x. Right now, at this point, if we were to plug in 0, right, we would get, that would go to 0, that would go to 0, that would go to 0. But everything else I think is okay. We wind up getting 2 plus 4 all over negative 1, which is negative 6. So not what I would expect here. Turns out the answer to this problem is actually negative 6. Well, funny how that works out, huh? That's what you get. All right, now number 5 is just straight up tricky. This is just a straight up tricky problem. We have x minus ln of x. And this is one of those problems where we have infinity minus infinity. But the tricky thing here is that we don't have a common denominator, right? This is not a fraction. Can't really do anything about that. Yeah. I mean, my thought is maybe do one of those ln tricks. Try taking e to both sides. We could see if that works. Another trick, actually, one thing I think we're going to do. Now, here's what I'm going to try to do in this case. I'm hoping this works. Instead of writing it as x, I'm going to write it like ln of e to the x. Right? See how I sort of did the inverse ln of e to the, cancel each other out? And this is another infinity minus infinity. But we do get to write it like this. And that's right because we're using a log rule. And so that's maybe a little bit nicer, because what's happening here? Well, we have a limit as x approaches infinity of ln of e to the x over x. And so to see what's happening here, we just sort of need to figure out what's happening with e to the x over x. And I don't know, is that obvious? I'm not so sure. But I'll let you show that the limit as x approaches infinity of e to the x over x equals infinity. And so this right here does equal infinity. Okay. And number 6 for this guy, this is going to be a tough one, right? We're going to let y equal this limit as x approaches infinity of this guy. And so when we do the ln of both sides, we're going to say ln of y equals ln of this. Remember, just stick ln right inside that limit. And this equals the limit as x approaches infinity. 1 over x ln of x. Which is really the same thing, just to rewrite this more suggestively. Ln of x over x, right? And this is an infinity over infinity indeterminate form. And so we can use L'Hopital's rule. And we can show that, well, I guess we get limit as x approaches infinity of 1 over x over 1, and this winds up equaling 0. Okay, so our answer is 0, right? Right? Now be a little careful. Ln of y equals 0, and that implies that y equals e to the 0, which is 1. So this winds up equaling 1. That's all we've got.